So here actually like we know the data communication is between the transmitter and receiver, right? So
Mm.
basically I was telling like in the mail example, like whenever you want to send data and receive at the another end, so we should actually properly attach certain uh, header to it, correct? So that like
Mm.
at the receiving end, like he can receive it properly. And whenever the data transmit through various channels, there is always a possibility of error, right? We should have a proper error control and flow control. So error control is like we saw in the previous example also in the file side. What we do, like we usually add that checksums and
X.
ERCs, right?
Yes.
Yes. So in the flow control, right? So they like here they have mentioned two situation. So if the items are like this is actually not with respect to the communication aspect, like this the as a producer and the consumer example they have given. So items are produced faster than that can be consumed. So consumer can be overwhelmed and may discard some items in the sense. So it's a demand supply thing. Uh, so for example, like you assume um, like right now the tomato scenario. Now actually like we have why the price is inflating is because like the demand supply chain is there is an imbalance. Like whenever like we want certain amount of tomatoes, like that much amount of tomatoes are not available. So that's why like the price is getting inflated. Same way, if like huge amount of tomato is like getting produced and like nobody is there to consume, lot of things will be get discarded, right? That's why price will drop. Same way, for example, if receiver can process some 10 megabits per second, okay, that is the maximum capacity what it can process. And if the transmitter sends at 20 megabits per second, so he will just discard the rest of the 10 megabits per second,
Right.
right? It's actually because
Yes,
he
sir.
cannot process that. So that's where we have to have a proper flow control between the transmitter and receiver, so none of the data will be lost. So that is where the flow control will come into picture. So usually we have something called buffer. Okay, so what we do at the transmitter and receiver end, we will have buffer. So it is something like if at the higher end, like network layer is providing huge chunk of data, what we will be doing for some time, we will store in the receiver itself until the receiver side that data gets consumed. So once the data gets consumed, then we will discard it. I mean, so it is something like now let me assume uh, the water scenario. Okay, so in your house, like if you want to consume some water, what do you do? Like you store that somewhere as a storage buffer, like in some tanks or like some that like for some time, and like you will actually as and when it is required, you would draw that water from that some, right? The same way,
Yes.
you will store that temporarily somewhere in the memory, and whenever that data like matches with the receiver, then we will push that. Okay, that is actually basically the flow control of the data. Okay, basically the mechanism we call it as buffering. Okay,
Yes. Yes.
in case of error control, we already discussed like what are all the mechanism we saw. Like we saw something like FPC and checksum we saw, right? So we saw how to compute the CRC, right? We saw like it's a single bit checksum or like computing the CRC by division method. Those are all error detection mechanisms, right? So those are the two methods, and in the process of error controlling and detection, we have something called automatic repeat request. So that is something like the receiver will. So for example, in the receiver side, if I detect an error, receiver will tell to the transmitter that like so whatever the byte you have sent that was erroneous. So he will send the ARQ request to the transmitter so that transmitter will retransmit that packet. Okay, ARQ is
Yes.
automatic repeat request. So repeat in the sense, okay, whatever. So usually it's like something like whenever you tell tell something to someone, and if he doesn't listen it properly, he will say, right, excuse me, can you please repeat? The same way, receiver, if he doesn't receive properly and if he is not able to decode it, he will tell to the transmitter through some, again, one more packet, saying that, like, boss, whatever you have sent, it is not clear to me, you can please resend it. Okay, that is error.
Yes.
So error control is implemented in two methods. One is CRC way, like which we already saw, like how to create the CRC using division method. So in the header,
Yes.
we will attach the CRC, and in the receiver side, he will check that CRC. You should see that reminder as 0. So then it is
Oh,
like the whatever the data we transmitted, that is not erroneous. Okay.
yes.
Usually there are two ways. I mean, so for example, if it is a video data or like audio data, so if one packet is not received, one or two packet is erroneous, is it viable to request back saying that, like, please send it? So it is like not in real time, right? Even if we send it again, so whatever we had to display, that actually the time duration is gone. Like, it is not the real time. So in video and audio time, audio data, the re-requesting, automatic re-request is not viable solution. So it has to be like the data will be just discarded. If it is anonymous, you will not consider, especially in wired LAN or like Ethernet. So in method 2, if like it is like if the frame is corrupted, it is not discarded. Okay, it is actually we have to say, like, by acknowledgement to the transmitter, that I haven't received properly, so that what he will do, he will retransmit. Okay.
Yes.
So we have various protocol. In for the noiseless channel, like your wired channel and all, it will be less noisy compared to wireless channel, right? So simplest protocol, like just discarding, or another is stop and wait. Okay, in noiseless channel. Another, in the noisy channel, stop and wait with the acknowledgement. Go back and acknowledgement. Selective repeat acknowledgement, ARQs. So that way we have various protocol. So in the data link layer, basically we will be studying this protocol. Okay.
Yes.
So simplest protocol, if you see here, no error or flow control. Like simply sending the keep on sending the data. So even if it is error, I'll not bother about it. If you see the data, usually we get it from the network layer. We'll get to the data link layer, send the frame. Data frames will be sent, receive the frame. Data link layer, we will get the data, will deliver the data. Right. So in the algorithm side, in the repeat forever in the sense, I'll be like, from the request from the network layer, you will keep on sending. We will not bother whether it is converging, whether like any flow control required, such things. Okay. So if you see here, like the algorithm, while true, in the sense infinite loop, wait for an event from the network layer. If event is there, get the data from the network layer, make a frame, send a frame. At the receiver end, wait for an event, like if I get the arrival notification from the physical layer, now receive the frame from the physical layer, extract the data, that is remove the headers, and deliver the data to the network. Hope you are clear.
Yes, sir.
If you see here, request, send, request, send, send. So there is no feedback mechanism, right?
Feedback. Yes.
Stop and wait protocol. Here, what we do, we get the data, we send the frame. Okay, we wait for that, the physical data link layer, we wait for the acknowledgement from the receiver. Okay, so get the data from the here, he will send the data, we'll wait for the acknowledgement.
Right.
If you see here, uh, can send true, like allow first frame to go, wait for the event, that is from the network layer, event request to send, like from the network layer, and can send, in the sense like can send will be high only whenever we receive the acknowledgement upcoming lines we have that get the data, make frame, send frame, can send false, because can send false will become true only when we get the acknowledgement. Whenever we get the acknowledgement, so we will receive a frame, can send will become true, right? And this
Yes.
request will be satisfied, and again we will get the data, make a frame, can send the frame, and then we will make it false, and we will again wait for the acknowledgement. This is an infinite loop, keep on happening. Clear?
Yes, sir.
At the receiver end, receive the frame, extract data, deliver the data, and send frame, send the
Send the
acknowledgement. See here, receive the data, send acknowledgement, receive the data, send acknowledgement.
Yes, sir.
So in the noisy channel, it is little tricky. We have stop, wait, automatic repeat request, go back and automatic repeat request, selective repeat request. So these requests we have. So for error correction, right? For instance, in the previous cases, noiseless channel, we didn't resend the data, right?
Yes,
We just
sir.
like if we receive the acknowledgement, we send,
We send again.
but we didn't resend the data, same day. So here, actually, for the error correction, if we receive the acknowledgement, if we do not receive the acknowledgement, then what we do? Actually, we resend the data. So for that, actually, here we have to maintain a buffer. So here we will store somewhere. See here, can send the data, send the frame, we receive the data, deliver the data, and again we send acknowledgement. Okay, so it is actually, see, algorithm at the sender side. If we time out, okay, if we time out, then he will resend the same. Okay,
Yes.
in the sense, if we do not receive the acknowledgement at all, then we will resend that. If you see here, can we send the data initially to while true is infinite to wait for event request to send and can send, initially it will be high. So get the data, make frame SN, store frame SN, send frame SN, that is the current frame, start timer, and I will go for the next frame SN plus 1. Can send will become false and wait for an event. And if we get the acknowledgement, receive frame, if not corrupted and acknowledgement is SN, then stop timer, just discard that previous frame, and can send will become true. Okay. Uh, Again, I will also parallelly start the timer. If I don't receive any acknowledgement, again I will reset. You got it, right?
Yes, sir.
See here. Send, if it is didn't receive here, again he will reset. And we send it, and like acknowledgement missed, again we will reset. So various problems are there. Third, I sent the data, it didn't reach. Okay. This is a good case. Here, we received the acknowledgement, we do not reset. And here we send, we lost the acknowledgement. Timeout, again we send the data. So these scenarios you should show, actually see. Get the acknowledgement, frame 1, get the acknowledgement, frame 0 didn't reach. So again we will start
Yes.
from frame 0, frame 1, this acknowledgement didn't reach. Again we will restart, frame 1, frame 0. It's like this, it will keep on happening until we get the proper data. Clear?
Yes, sir.
This is same flow diagram. I mean, you can just go through this. So assume that in a stop and wait ARQ system, bandwidth of the line is 1 Mbps. Okay. So 1 megabits per second I am transmitting. Okay. 1 bit takes
Yes.
20 millisecond to make a round trip. In the sense, round trip in the sense to go to the receiver and return back. Okay. What is the bandwidth delay product? Okay, that is one thing. So if you remember, like initial discussion, we discussed all these components, right? Bandwidth, delay, product, and all. If the system
Yes.
data frames are 1000 bits in length, what is the utilization percentage of link? Okay, so bandwidth delay product is product of 1 Mbps data rate, right? 1 Mbps into 20 milliseconds directly 20,000 bits. That is a bandwidth delay product. Okay.
Yes.
Just multiply those things. So the system can send 20,000 bits during a time it takes for the data to go from the sender to the receiver and come back. Okay. However, the system sends only 1000 bits. We can say the link utilization is 1000 by 20,000. That is 5%. So here you are saying, see, 20 millisecond for the round trip, right? In 1 second, how much it can send? You have to compute. So 20 millisecond, 1000 bit. In 1 second, how much?
Okay.
So, or actually see this bandwidth delay product if you want to see. So in the 20 millisecond, 2000 bits it can send. Right? 20,000 bits we can send in a bandwidth. But in 20 millisecond, how many we send? We just send 1000. So directly you can divide out. Send by 20,000. It is 5%. Okay.
Yes.
So this protocol go back and automatic repeat request. So here previously you saw like it was like until that transmission, one packet transmission is not completed, we were not going forward for the next transmission, right? So here,
Yes.
what we do, actually we will push multiple packets into the pipe. Okay. So at the receiver end, if any one of the packet is not correct, he will re-request that particular packet only. Okay. So here sequence number is important along with the frame. You're getting?
Yes.
If you do not get, please let me know. So if you see here, so 0, 1, 2, 3, 4, 5, 6, 7, everything they pushed. So like a
Yes.
sliding window. Okay. So at the receiver end, he will be keep receiving, but if he miss any of the data, right? So he will just intimate back to the transmitter saying that this particular sequence I need to receive. So the transmitter will send only that particular date.
The
Clear?
sequence number means? The sequence number means?
Sequence number means packet number. It is like, so actually you can assume, so they will give you some tokens, like in the bank, they give you token, right? So that like based on the token, you are going to collect the money. Same way, for the packet, we will assign one incremental counter value. 0, 1, 2, 3, 4, 5, 6, 7, 8, something like that. So it is identity. So parallelly, until we get the acknowledgement, we will maintain the buffer of it also locally. So
Yes,
10
sir.
packets is there. So that 10 packet copy I will maintain. So at the receiver end, so after timeout, right, I may not receive the acknowledgement for the 8th packet. So otherwise, like 1, 2, 3, 4, 5, 6, 7, and 9, 10, all this I have received. Then what it will do? At the receiver, transmitter will transmit only that 8th packet. Like,
Yes, sir.
got it, na?
Yes, sir.
So this is actually sliding window in a sense. It is like 0, 1, 2, 3. In that way, it will keep incrementing that. Okay. So GBN is the sender window size. Okay, that is actually how much. So I said that packet number locally it has a buffer. So how much buffer it can store? Like this, that should be sequence number maximum 0, 1, 2, 3, 4, 5. The sender can maximum store 10 bits. So what it can do, like 10 packets. So maximum sequence number will be maximum 10. Again, it will repeat from the 0. Okay. So how much it can store? That is the maximum size. Okay, sender window size. Clear?
Yes, sir.
If you see here, like they have taken 4. The 4 is the buffer size. So 0, 1, 2, 3. So at the receiver end, we will receive 0, 1, 2, 3. Normal.
2, 3.
Okay.
Yes, sir.
If, for example, 0, 1, 2 didn't reach, 3, 4, 5 it reached, but it didn't send the acknowledgement. So what it will do, transmitter will send, so 2 was abundant, so it sent true. 3, 4, 5 didn't receive, so again it will send 3, 4, 5 after. Got getting na?
Yes, sir.
Okay. Same thing they have represented in terms of algorithm. So these steps you can just go through. But you got the concept, right?
Yes, sir.
Try to understand this flow diagram. So if you understand that flow diagram, it is straightforward. So here, right, the selective repeat in the sense, so he will actually at each frame, right, he will decide whether the acknowledgement is required. So for all data, we may not require acknowledgement. Some data might not be the mission critical, right?
Hmm.
So what it will do, like for example, I have 3 frames, 0, 1, 2, 3. So 2 and 3 is like not important for me, for example. Huh? So what I,
Yes, sir.
0 and 1 is important. So what I will do, like for 0 and 1, I will decide, I will wait for like 0 and 1 acknowledgement. So if 2 and 3 acknowledgement, if I don't receive also, I will not bother. I mean, I will not receive. So that like, again, our efficiency can be improved. So it is like data efficiency improvement. That's it. Clear?
Yes, sir. Yes, sir.
No. And next method is actually heavily used in the industry, piggyback method. Piggyback method in the sense, whatever I send the data, right, along with the acknowledgement, I will send the data also, okay, to the receiver. So what receiver will do, it will tell the transmitter, okay, whatever the receiver received that data and he sent it back, right? Whatever he received, that is correct. So it is like 3 times acknowledgement. You will see, transmitter will send the data, receiver will receive the data. So receiver will send back the acknowledgement
Hmm.
and data to the transmitter. So he will recheck the data, whatever he transmitted. If both are matching, he will acknowledge again to the receiver saying that whatever you had received previously, that's correct. If it is not, then again we will have that retransmission, all this mechanism. Clear?
Yes, sir. Yes, sir.
Next is HDLC. One second. So HDLC is nothing but high level data link control. So it's a bit oriented protocol. Uh, it is again for the acknowledgement, okay, for the giving acknowledgement. So we have 2 modes. One is like normal response mode, another is asynchronous balanced mode. So in the normal response mode, it will actually send the command, the receiver will send the response, okay. So in case of asynchronous balanced mode, so we will have multiple nodes actually. See, for the multiple node, it will send one request and multiple node will respond. So here it is actually one-to-one protocol in the normal response mode. Asynchronous response mode will have multiple receive. Okay.
Yes.
The same thing what we discussed. So in SDLC, we have three types of frames. One is information frame, supervisory frame, unnumbered frame. Okay, so it is actually something like each frame, right? It will have its own functionality, and the name itself you can check, right? So information frame, something like which carries our data. Supervisory frame is like your flow control, address control, controlling data. Unnumbered frames are like some guard bands. Okay, so if you see here, the iframe are used for transport user data, like your video data, audio data, or like any text data, and control information relating to user data. S frame is used only for transport control information, like I was saying, some flow control related things, controlling some switches, all these things. Okay, U frames
Yes.
are for user management or system management. So this actually you can decide what should be in what way you want to use them. Okay,
Yes, sir.
you can see iframe here. So we will have one flag, and we will have one address. We will have one control. Okay, and user information. And FCS is
Yes.
actually guard band. Okay, then again one flag will be there. So S frame here, it's a small user information will not be flag, address, control, FCS. In U frame, management information, you can add anything based on your requirement. Okay, so always HDLC flag is this one, FE will be used as HDLC flag, and the flag what he used in this as a flag, right? So here in the address or user information, it won't be repeat. So FV will not be there in the data and user information. So if FV occurs, then what we do? We do bit stuffing, that we understood, right? Previously we saw byte stuffing and bit stuffing. Whenever the data in the data, the flag or header is repeating, what we do? We do bit stuffing. Clear?
Yes, sir.
So you can see the description. So address field is actually where the data has to go. That is flow control, right? Flow control. So control field, if you see here, we have control field that is for flow control. Okay, I mean, it basically, we saw the request, right? Saw the example, right? If overflood happens, then receiver cannot handle. For that purpose, we use user data is actual data, information data, video, audio. FCS is error detection field. Like if you want to add some CRC, we found that like CRC computation logic, right? Previously. So if you want to attach that CRC data with along with the HDLC data, then we update that. Okay.
Yes, sir.
So this control field and stuff like that, we will see tomorrow. Okay?
Yes, sir.
Yeah. Any questions?
Sir, can you share the recording?
Sure, sir. I can share.
Yeah.
Old recordings also I have. I'll search and up. Okay.
Yes, sir.
Okay. Thank you.
Thank you, sir.
Please remind me also later. I mean, once I may forget, like if you don't receive the link for
Yes.
recording, you remind. Okay.
Yes, sir.
Okay. Thank you.
Thanks.